Bismillahirrahmanirrahim. Dear students, welcome you all to the industrial pharmacy class. Recalling from the previous lecture in which we discussed the fluidized bed dryer, that is one of the class of dryer example which we have classified on the basis of several criteria, and one base that we have discussed in the previous lectures, the classification of dryers on the basis of solid material handling. One of the class of the dryer, that is static bed dryer, and the example is freeze dryer. And in today's lecture we will discuss the freeze drying and the freeze dryer. Dear students, the main objectives of today's lecture is to learn about the freeze dryer, including the principle, construction, working, advantages and disadvantages, as well as uses of freeze dryer. Dear students, after the completion of this lecture you will be able to know about the freeze drying principle, at how a freeze dryer work, and what is the principle behind working, and the material of construction, and how it works, the different steps involved in the processing of a material for drying. If we keep it for drying in the freeze dryer, then what will be the several steps, and as well as advantages, disadvantages, and some of the materials example which can be processed for drying by using the static bed dryer type, that is freeze dryer. Before going to discussion on the principle and several steps, first of all I would like to tell you about the background of the freeze drying, that many of the pharmaceutical products lose their viability, that is the activity when they are in the liquid state, and readily deteriorate if they are dried in air at normal atmospheric pressure. If we kept the material for drying purpose and the normal atmospheric pressures, and we want to dry it in air, then the material activity and the liquid state will be affected, and it will be lost. These pharmaceutical materials may be heat sensitive, that's why they are readily deteriorated, or they may be react readily with the oxygen if we kept it for drying in air at normal atmospheric pressures. Because of the readily reactivity with oxygen or the heat sensitivity of these pharmaceutical materials, we may be unable to maintain its viability. So it is the need to maintain the stability of these products, and the stabilization of these products may be maintained by dehydration to a solid state. If we dehydrate it to a solid state, we convert it to the solid state, and in this case, without converting it to the liquid state, if we maintain their stabilization, want to maintain the stabilization, in this case the material must be dehydrated to a solidification phase. One of the concepts that you know about the sublimation, we're calling from the definition that sublimation is a process in which the solid material is directly converted into the vapor state without converting it to the liquid state. And we have discussed in the previous this one that if the material are in the liquid state, they will readily deteriorate and their viability will be lost. So it is necessary to maintain its stability. In order to maintain the stability of these products, the material to be dried is first frozen and then subjected under a high vacuum to heat that is supplied by conduction or radiation or maybe by both, so that the frozen liquid that is in the solid state, because the liquid is no more in the liquid state because it is frozen, leaving only the solid and dry components of the original liquid. So it is done. So the process of sublimation is required, and the material to be dried is kept frozen first of all, and then it is subjected to a high vacuum, under a high vacuum to a heat supplied by the process of conduction or radiation or both, and the frozen liquid sublimes, that is the liquid is in frozen state, leaving only the solid material, and the liquid is sublime, that recalling from the definition that the sublimation is the process in which the solid material is directly evaporated. Now the liquid is in the dry stage. At this stage the liquid is in the frozen stage, and the dry components of the liquid is hereby solid is kept, and the liquid is removed from the composition or from the material. Freeze drying is a process that is also known as lyophilization, and this part we will discuss the principle and freeze drying. Water that is solvent is removed from the frozen state by the process of sublimation. Again, recalling of the sublimation, that is the direct conversion of water or liquid from the solidified state into the vapor state without conversion into the liquid phase. Remember that in the sublimation there is no conversion into the liquid state, the direct conversion from the frozen state to the vapor state is being processed, because as you know that we have discussed in the start of the lecture that some of the materials, when they are exposed to the process of drying and they are converted into a liquid state, they lose their viability, and deterioration may be occur because of the reasons that we have discussed earlier. Solid liquid vapor equilibrium phase diagram of water is useful to decide the experimental condition that what is to be kept. The vapor solid liquid vapor equilibrium diagram is necessary and very much useful to decide which we kept some of the experimental conditions like the temperature and pressure, and for this purpose the solid liquid vapor equilibrium phase diagram is required. The drying is achieved by subjecting material which is to be dried and these are subjected to temperature and pressure below the triple point. Under this condition, any heat transferred is used as latent heat, and ice that is in frozen state sublimed directly into the vapor state. If we kept the temperature and pressure below the triple point that is mentioned in the solid liquid vapor phase diagram, the water vapor is removed from the system by condensation, and a cold trap maintained at a temperature lower than frozen material. You can see the schematic pressure temperature diagram, that is a solid liquid vapor diagram, which you can see on the x-axis that is temperature is kept, while on the y-axis pressure that is kept. And you can see on different graphs that's on the top you can see the solid ice at these conditions, the solid ice and sublimation curve over there, and the vapor state and the liquid state, and the triple point that is A. Below this point, that is the triple point that we have mentioned, that if we keep the pressure and temperature below this triple point, in this case the material is dried, and by achieving the condition of temperature and pressure below this triple point. Now we will discuss the construction of freeze dryer. The freeze dryer consists of several parts, like the drying chamber that you can see in the diagram below, that on the left side that is mentioned, that is the chamber that is termed as drying chamber. In this chamber you can see the two trays in which the substance to be dried are kept, and drying chamber in which trays are locked. In trays materials are substances or frozen substances are kept, and this one is termed as one part that is drying chamber. The second one is the heat supply in the form of radiation source, that is heating coil. Heating coils are also there. It is a heating source because heat is to be supplied, that is in the form of radiation source. The heating coils are there in the freeze dryer. Vapor condensing or absorption system is over there. That is a condenser on the right side. You can see a condenser that you have seen the condenser in the routine used refrigerator as well. Vapor condensing or absorption system is one part of the freeze dryer, and moreover on the top of the condenser you can see a diagram, and the diagram that is to vacuum. That vacuum pump or steam ejector or both are installed, or one of the part of the freeze dryer. So these four parts are necessary for the freeze dryer: drying chamber, heat supply, vapor condensing or absorption system, vacuum pump or steam ejector, or both system may be part of the freeze dryer. Now we will discuss the working of the freeze dryer. The working of freeze dryer consists of the following steps, including the pre-treatment and preparation. In the preparation and pre-treatment, the volume of the solution introduced into the container that will be further subjected into the trays. You have observed in this one that chamber that consists of trays, and the trays the materials are locked, which are the material which are to be dried or the frozen substances. In the first step, the volume of the solution introduced into the container is limited by its capacity. According to the capacity, the solution is limited. If we have small volume capacity, then we will keep it in the small container. Therefore, pre-treatment is essential because we have low capacity, small capacity, and that's why the pre-treatment is necessary, because the larger quantity, the larger volume cannot be processed in this piece of equipment. The solutions are pre-concentrated for this purpose. In order to reduce the volume, they are pre-concentrated under the normal VQ tray drying. This reduces the equal drying by 8 to 10 times. The drying time will be reduced, that is 8-fold to 10-fold times reduced, because pre-concentration is done for that particular solution. The volume is reduced by using the normal vacuum tray drying process. We will reduce the volume by pre-concentration under the condition that is provided normal vacuum tray drying. And what will be the benefit? The benefits will be that the equal drying time will be 8 to 10 times reduced. That's why pre-concentration is done. The second step is pre-freezing to solidify water. After the pre-treatment and pre-concentration, the vials, infuser, or bottles in which the aqueous solutions we want to dry, expect are frozen in cold shells, and the cold shells having the temperature that is minus 50 degrees centigrade. The normal cooling rate is about 1 to 3 Kelvin per minute. That is the cooling rate, so that large ice crystal with relatively large holes are formed on sublimation of ice. This is also responsible for giving a porous product. Why this pre-freezing or solidification of water step is important, and that is not only responsible for the giving a porous product, but also large holes are formed on sublimation of the ice, and the cold shell having the temperature is given, and the normal cooling rate is also given, that is 1 to 3 Kelvin per minute. Because to provide large ice crystal, relatively large holes are formed on the sublimation of the ice. The third step, that is the primary drying. It means sublimation of ice under VQ. The temperature and pressure should be below the triple point of water. Remember that it is kept for water, that is 0.0099 degrees centigrade, that is the temperature, and the pressure is kept 4.579 mm of mercury for sublimation when water is alone present. If we have only water present and we want to remove the water, then we have to keep the conditions below the triple point. The below triple point is point, you can see on the diagram, that is for water diagram, that is below 0.009 degrees centigrade, and that is the temperature we will keep, because at that particular point, that is a triple point, we have to keep the temperature and pressure below this point, and the temperature, that is 0.0099, and the pressure is you can see on the left side, that is 4.579 mm. We have to keep the temperature and pressure below this. In case of water, the temperature and pressure is reading is that one. At triple point, we have to keep it below this temperature, and as well as the pressure below this pressure. In case the only water is present, remember that it is a condition, because these are the condition for the triple point of water. When only water will be present, then these are the temperature and pressure respectively, and we have to keep below this. When a solution of a solid is dried, the depression of freezing point of water occurs. Hence, it is essential that the temperature be brought below the eutectic point. That is so it is necessary that the temperature be brought below the eutectic point. The temperature and pressure at which the frozen solid vaporizes without conversion to liquid is referred to as the eutectic point. Because we will sublime that particular material or solvents rather than to converting the liquid state, and the pressure and temperature at which the frozen solid, that is solidified solids, vaporize is converted into the vapors without converting into the intermediate step, that is liquid. That is point termed as eutectic point. Depending on the drug substances and dissolved in water, the eutectic point is determined. The usual range is from minus 10 degrees centigrade to minus 30 degrees centigrade. This is the usual range of the eutectic points, that at that particular points and the condition of 1 to 8 Kelvin below eutectic point is sufficient. The condition we have to keep because we have to reduce the temperature and pressure below this point, and 1 to 8 Kelvin below the eutectic point is sufficient condition. Then vacuum is applied to tune of about 3 mm of mercury on the frozen sample, and the temperature is linearly increased about 30 degrees centigrade in a span of 2 hours. Heat, that is about 2900 kilojoules per kg, is supplied, which transfer as latent heat energy, and frozen state of the liquid water, that is ice, sublimes directly into the vapor state. As the drying proceeds, thickness of dry solid increases. Primary drying stage removes easily removable water about 98% to 99%. In this step, 98 to 99% water, that is the easily removable water, is removed in the process of the stage of the primary dry. After the processing of the 98 to 99% removal of easily removable water, the next step is process, that is the secondary drying. It is the removal of residual moisture under high vacuum. The temperature of solid is raised to as high as 50 to 60 degrees centigrade in this step of the secondary drying stage, but vacuum is lowered below that is used in the primary drying. Here the temperature is raised, but the vacuum is lowered. That is, we have kept in the primary drying, then we have to further lower the vacuum. The rate of drying is very low, and it takes about 10 to 20 hours, and this step of the secondary drying, the rate of drying is very much low, and the time taken is too much high, that is 20 to 10 to 20 hours. And after the completion of this step, the packaging is done. After vacuum is replaced by inert gas, the bottles or vials are closed. Remember that vacuum is to be replaced by the inert gas, and then we have to close the bottles or vials in which the materials are dried. Now in this part of the lecture, we will discuss the uses of freeze drying. The method is used for products that cannot be dried by any other heat method because of the several reasons that we have discussed at the start of the lecture. It is used for drying of number of products, including the following products like blood plasma and fractionated product. The fractionated product of blood may be dried by using the freeze drying process. Bacterial and culture, viral culture, vaccines such as BCG, yellow fever, smallpox can be dried by using the freeze drying process. Antibiotics and plant extracts, as well as steroid, vitamins and enzymes, and some of the antiviral drug Radavir, that is used for the current COVID-19, and that is also available in the freeze-dried form products, and they must be reconstituted, and the freeze-dried products have a better solubility because of the porous product is formed in this freeze drying process. Now we will discuss after the usage advantages of the freeze drying process and why freeze dryer is preferred over the other dryers. There are several reasons, several advantages due to which we select the freeze drying process. Some of the advantages include the first one, that is thermally biased substances can be dried and denaturation cannot be happen and does not occur, and migration of starch and other solute does not take place, and moreover moisture level can be kept as low as possible compared to the other process of drying, and product formed by using free drying. If you dry product and the dried product is porous and uniform, which gives ready solubility. A readily soluble product will be there because of the porous and uniform drying process, and sterility can be maintained without contamination because it is not converted into the intermediate step, and the product is converted directly into the vapor without converting into the liquid state from the solidification state. Material can be dried in its final container, such as a single dose and multiple dose container, and the final container the material may be dried. If you dry the material in the final container, then it is termed as terminal uh, drying, and if you process the sterilization in this step, if you want to sterilize the product in the final container, then it is termed as terminal sterilization. But here in the terminal container, the final container, we can dry the material either it is a single dose container or it is a multiple dose container. There are several disadvantages of the free drying dryer. The product is prone to oxidation due to high porosity. Because of the high porosity, large surface area, therefore the product should be packed in vacuum or using inert gas. We have discussed in the packing that it should be replaced with the tube should be replaced with the inert gas while we are packing. Equipment and running cost is very high. It takes much more time. The period of drying is very high. The time cannot be shortened. That last step, that is the secondary drying, that having calling from date, in which step we have discussed that the rate of drying is very low and takes about 10 to 20 hours. The 20 hours, that is much more time, and lengthening of this time that is cannot be shortened. It is difficult to adopt the method for solution containing non-aqueous solvents because we have to keep the temperature and pressure below the eutectic point, and we have to determine the eutectic point, and if the combination of the non-aqueous solvents and the formulation, and we have to dry it, then we have to validate and adopt the method for that particular formulation. It is difficult task. References Luckman and Lieberman, The Theory and Practice of Industrial Pharmacy, 3rd edition, and as well as Orton Pharmaceutics, The Science of Dosage Form Design, 2nd edition, and pages consulted, and the Theory and Practice of Industrial Pharmacy, 52 to 64, and Orton Pharmaceutics, 390 to 93. Thank you all for your attention. Now, overview about the today topic, that is freeze drying. Principle, construction, working advantages and disadvantages, uses of freeze dryer. First of all, we have introduced the need of the freeze drying. There are some of the pharmaceutical products may lose their activity and the liquid state and deteriorate readily if they are dried in air and normal atmospheric pressure. So it is the need to provide the conditions which lacking this loss of the ability of the pharmaceutical products, and some of the materials may be heat sensitive. They may react readily with the oxygen, so in order to stabilize they must be dehydrated to solid state. And sublimation is a process which provides the conversion of the material to be dried, that is first frozen or kept in the solidified state and then subjected to heat under a high vacuum, and sublimation is done then. Then we have discussed the principle. The schematic pressure temperature diagram of water, solid, liquid and vapor phase diagram of water, the triple point, and the objective point, the temperature and pressure. And then we have discussed the construction of freeze dryer, including drying chamber, heat supply, vapor cancelling or absorption system, vacuum pumps or steam ejector, or both may be a part of freeze dryer. Then we have discussed thoroughly the different steps involved in the working of the freeze dryer, including preparation and pre-treatment, that why preparation and pre-treatment is done, and it is very much important because reducing the drying by 8 to 10 fold. The second step, that is pre-freezing to solidify water. Primary drying and the condition, the triple point of water showing the temperature and pressure. And then we have discussed that the easily removable water is removed by using the primary drying, and about 98 to 99% product is dried. The material to be dried is further subjected to the secondary drying step in order to remove the residual moisture under high vacuum. But remember that in temperature, the temperature of solid is raised 50 to 60 degrees centigrade, but here the vacuum is lowered below that we use in the primary drying phase, and the rate of drying is very low, and the time taken here, it is 10 to 20 hours. And then we discuss the packing and usage of freeze drying, some of the example of products that will be used. Advantages and disadvantages. Thank you all.